This unit is about two-column proofs, but before we march into proofs, let's do some reviews of equalities, okay? So first of all, addition property of equality says that if A equals B, then A plus C would equal B plus C. Subtraction property of equality, same thing, except that it's saying that if both sides subtract the same thing, they still equal A still equals B. Multiplication, it's very much the same thing. So A times C equals B times C. Division, still, if A equals B, then A divided by C should equal B divided by C. Distributed property, something we learned in Algebra 1. A times B plus C is A times B plus A times C. And substitution, if A equals B, then A may be replaced by B in any equation. Reflexive, it gets a little tougher. I like to think of reflexive property as a mirror. So for any real number A, it has to be a real number, A equals A. So I like to think about it in the mirror. It's a reflection of oneself, right? That's how I remember reflexive property. Symmetric property, if A equals B, then B equals A. Just switch it. Transitive property, if A equals B, then B equals C, then A equals C. This very much makes me think about law of syllogism. They're all related. Now let's see using properties of equality to do two-column proofs. What does two-column proofs mean? Two-column proofs is a common format to organize proofs. A lot of times we also see paragraph proofs when you write your papers in English, in philosophy in particular, you have to do paragraph proofs, right? Use logic reasoning. So for two-column proofs, on the left-hand side, we list all the statements. These statements are actually steps, which is written here. So really how you solve each problem, I'm just asking you to break it down step by step and put it in the left column. Then on the right column, I want you to list all the reasons, properties, laws, to justify why you just wrote down the step on the left-hand side. What are the things that can be used as reasons? I already mentioned properties. We just reviewed lots of properties of equality up on top. Definitions. Postulates. Postulates are common beliefs and theorems. It doesn't mention laws, but I would put laws in there. Law of syllogism, so on and so forth, right? So let's look at some practices here. It's column proofs, usually it's written in this format, given certain things, and then I'm asked to prove a statement. So what I need to do is I copy down the original problem, write down in the first row on the left-hand side, and then I would write down given right here to begin my proof. So first statement is always the original problem, and the first reason is always given. Then I begin to simplify that. I begin to solve the problem, and what I will do here is I will use inverse operation. I add 1 on both sides, so that's how I end up with the second statement, 4x equals 28. And what I did there was supported that. The reason I can do that is because of the addition property that I just reviewed above. So now I divide 4 on both sides. That's how I get to x equals 7. And obviously, in this one, I used division property. Okay, so now I just proved, what did I just prove? X equals 7, which is what I was asked to do originally. So again, start with copying down the problem on the left, write down given. Begin solving the problem, then illustrate the properties, the definitions, the theorems that you use to justify each step until you reach the final conclusion. Let's look at some additional practices here. If I have a over negative 6 plus 2 equals 5, so that's my original problem here. And so I write it down here, and then I say it's given. I'm asked to prove that a equals 18. So probably the logical thing to do is to subtract 2 on both sides. That's how I get to this second step. And I can do that because of subtraction property. That's the reason, right? That's what makes it right. Now I multiply negative 6 on both sides. So I multiply negative 6 on both sides. That's how I got to a equals 19. And that's multiplication property. Okay. Number 3 and number 4 are very much similar. I'm going to do number 4. I'll demonstrate number 4. Number 3 has, the only thing that you haven't seen is distributive properties. So that's the third step. The second step. Number 4, given 6x plus 7 equals 8x minus 17. So I have to write it down here. And then that's given. I have to prove that x equals 12. So what do I do first? Looks like I subtracted 6x on both sides. That's how I end up with 7 on the left-hand side, right? And I can do that because of subtraction property. And then I add 17 on both sides. That's how I end up with 24 equals 2x. And that's addition property. Because I'm adding, that's the action. Look, by the way, look for the verb. I'm adding, I'm subtracting, I'm multiplying. That gives you a hint of the property. Now I divide 2 on both sides. So that's obviously division property. I have 12 equals x, but I want to prove x equals 12. So I simply switch it. And when I switch it, that's symmetric property. Oops. Okay. So go step by step, finish 3, and I will do 5. 5 is not hard, but it's just longer and more steps. So again, first step is given. Then second step looks like what I did there was I got rid of all the parentheses by distributive property. I distributed everything. And then what did I do? Looks like that's how I got negative 3x. It's minus 7x plus 4x. This is not a property. Whenever I use a property to prove something, to rewrite the equation, it has to be an impact on both sides. This is simply an action of simplify, right? It's addition. It's not a property. It's an operation. And then from there on, I subtracted negative 12x on both sides. That's how I got to the step number 4. So that's subtraction property. And then I added 14 on both sides. And so that's addition property to get to step 5. And the last one is division. I divided negative 15 on both sides. Division property. Okay. Some people may want to do this. Some people may say, okay, if I do this, I have x equals positive 10 over 15. That's division property. And then you can further simplify that. So you add another step and say simplify. That's an operation. That's not a property. That's totally fine. All right, guys? So the next 2 pages has a number of practices. And the third page is a really good practice on the definitions of these properties. And I can tell you these are super, super important. And arguably this unit and the next 2 units are the hardest in the entire year, because now we're really in high school in geometry, we demand you to reason, to prove every single step. You cannot just say, oh, I think this is this and I guess this. And an educated guess is a good thing, but you still have to find the reasons behind it. And that's what helps us deepen our learning. All right, guys, I will see you in class. Bye.